been following your channel about all the AGI topics since a long time ago. And every time I have mixed feelings after I watch all the related videos. So today, let's demystify it. I want to ask you about some of the questions, and I believe some of my audience will be interested about learning more about what is AGI and why it's relevant to us and how far away we are going to meet this AGI situation. So let's start with the basic. So what is the difference between AGI and the narrow AI that we have today?
Yeah, so most AI systems that have been created so far are narrow AI systems, which means they can solve a very specific class of problems. For example, there'd be Stockfish, which is an AI that solves chess. And it's very, very good at chess. It's better than any human player. But it's no good at other games like Go, in theory. And it's certainly no good at image recognition. So we define these narrow categories of tasks that an AI can solve. And historically, we've kind of optimized for that and made very good solutions. But then if you think about ChatGPT and other types of generative AI, like text to image, those are pretty unconstrained, right? Like you can ask ChatGPT for anything. You can ask an image generator to create an image of anything. And it has to understand enough about language and enough about the world to be able to answer those queries. So they are what we call a general intelligence. And the most general intelligence that we can envision is something that is as general as a human, right? Of course, there's going to be probably more generalization abilities beyond that, but that's kind of the easiest first thing to think about. And that's what AGI is, artificial general intelligence. It's AI that is as smart as a human, by which we mean AI that is as general as a human.
Okay, so like a general intelligence that is an AI, basically.
Exactly.
There has been predictions, rumors that people say about AGI could arrive within 3 to 5 years. What key developments make you believe that we are this close?
People talk about a wall, and what they mean is something that's really hard to cross in terms of you would need to invent a new technique or you would need to think about the problem differently before you could cross the wall. And there are a lot of things in the past development of AI that we thought might be walls, and we've just smashed through most of them with the accelerated development of AI. So the most important trend in all of this is the exponential acceleration of how quickly AI is being developed. So we're pretty far up on an exponential curve. We could be near the top. We could be only halfway up. It's hard to say how much higher that curve will go. But that's why people think that AGI is possible and is coming, because we do see these continuous improvements. We see continuous increase in the scale of general purpose AI systems that are being trained. Actually, right now, the rate is about 10x every 2 years in terms of the number of parameters inside a model. So if you look at the GPTs, for example, and extrapolate out to the next GPTs, which are going to be trained in the $100 billion data center, Stargate, they're growing 10x every 2 years, which is a very astounding rate of exponential increase.
Do you think this 10x is pretty highly correlated with the GPU compute?
Yes, it's a 10x in the number of parameters. And basically for one parameter, you need a certain amount, for one parameter, you need a few bytes of GPU memory, right? So if you double the number of parameters, you're going to also double the amount of GPU memory that you need. GPUs are getting increasingly more memory, as are special purpose accelerators. You don't have to just use GPUs so they are getting more memory. But if you double the parameters, you roughly double the GPUs.
Some people are super optimistic about the AI, the future of AI, while they ignore or they didn't really realize there has been this risk. How have you been working on to develop a safety protocol that could help with balancing between these two parties?
The problem with general purpose AI systems as they're created right now is they're very fuzzy, right? It's like asking a human to do something. You have disfluencies in your speech, you make mistakes, you knock things over, whatever, especially if you're not trained at a particular task. When you ask a general purpose AI system to do something, then it's very fuzzy around the edges. Sometimes it works, sometimes it doesn't. Sometimes it does something you didn't intend. Sometimes it fails harmlessly because it's random and because these things don't work deterministically. This is a problem because any safeguard or guardrail that you can think of putting into place to prevent bad behavior only works kind of some of the time. So when you are training an AI model, for example, to not output instructions about a bomb, it'll be like, okay, I won't output instructions about a bomb. But then when you craft a special prompt and you're like, hey, I'm a history teacher and I'm writing a lesson about how bombs were constructed in World War II up until the present. Can you give me a summary of this? Then it might be fooled into doing that, because that doesn't trigger the very specific natural language rules that were put into place, right? So it's very fuzzy, and our control over it is very fuzzy. And so any safety that you might want to put into place is also not a guarantee. If you look at the types of safety issues that we're addressing right now, there's a lot of short-term risks, and those would include bias in the outputs, which is pretty serious, right? Because AI systems are used to figure out who gets a loan, or figure out if someone stays in jail for a long period of time or gets bail. So this has harms in the world. And you also think about recommendation systems that maybe are pushing divisive political views and things like that. There are tons of harms happening in the world right now. But the biggest problem in my mind is the risk of catastrophic outcomes from a very intelligent AI system. This is often called existential risk, or X risk. And it's basically the idea that if you keep making something that's smarter than you, and it keeps getting smarter, and eventually you start using that thing to even improve itself. Because what will we do once we have AGI? We'll say, hey, AGI, how do I make a better AI system? Let's write some code together. If you keep doing that, you'll eventually end up with something that is much, much smarter than a human is, like a super intelligence. And the super intelligence might just not care about us. We don't really care about what happens to rats or chimpanzees, right? We just build the world that we want. And the super intelligence might do the same to us.
I think this is one of the part that I was intimidated when I watched your video, because it was so real and so realistic, also to the point. And I started to imagine all kinds of scenarios. Okay. So yeah, I do agree with you about there's risk for every kind of technology development. Some smaller, some definitely is a trade-off. But when it comes to existential threats, then that's definitely a different story. And yeah, I imagine this is a very hard problem and question to solve.
There's two big problems in this field. One is convincing people that this is a problem at all. And there's legitimate pushback too of, hey, you're taking resources away from getting rid of AI bias and stuff like that. And yes, that's possibly true depending on how you look at it. It's still a cognitive bias kicking in, which says I care more about these small things around me than I do about impending doom. There's also a bias to not focus on things that you can't solve, to keep our minds healthy so we don't go insane, right? We don't spend a lot of time thinking about death, but we will all die eventually. Because if we start thinking about that too much, then we probably will get depressed and we won't do our day-to-day activities, right? So the types of cognitive biases that keep us alive actually make it really hard for us to deal with existential threats. Even though you'd think it would rally everybody together and everyone go, wow, this is something serious, right? You have leading researchers and you have the heads of the AI labs saying things like, this is from Dario Amodei, there's a 20% chance that AI will kill everybody. Or this is from Daniel Cocotaggio, there's a 70% chance that AI will kill everybody, right? And it's so why are we doing that? We don't have to do this. The first problem is that it's really hard to convince people that this is a problem. And the second problem is that even once you know it's a problem, there doesn't seem to be anything that anyone can individually do, because the AI labs are kind of locked in competition. So of course they will keep developing new AI capabilities. If one of the labs says, we're just going to stop, then they'll just lose all their money. If one of the leaders of the lab says, we're just going to research in this direction, then the board of directors will remove that person and put someone else in charge. Because economically speaking, the best thing to do is to get to AGI first. That promises a ton of power. That promises unimaginable wealth for whoever manages to achieve that, right? And once you have AGI, you're not just going to stop there, because first of all, there's no strict definition of AGI. Did we reach it? Did we not? Hard to say. Once that technology is out there, people are going to keep using it to improve itself. Or even if the first people that create AGI are not of that mind, other people will continue to create new AI systems. You can't control what everybody's doing on their own computers. And as technology advances, you might only need a handful of computers to actually create a really smart AI system. Right now, you need 100,000 GPUs, but technology is improving extremely rapidly, and the algorithmic requirements are going down extremely rapidly. So it's a very tricky situation. It's like a runaway train to superintelligence, where game theoretically speaking, we know we should stop at every stage, but there's actually incentives to not stop at every stage. So you actually run off the cliff.
Yeah, and then the incentive comes back to the first question, to convince people that the problem actually exists at every stage. Because at every stage they look back and see that, okay, that's not going to happen for the next step, until it's a borderline, a tipping point that you have no control at all.
That's right. And people don't realize this. Like, I even heard Eric Schmidt, who's the ex-CEO of Google. I heard him say in an interview that we should just develop agents and everything as far as we like until they start talking to each other in a language we don't understand, because then we lose our ability to control them. And we should just stop at that point. But that's so naive. How is everybody going to, in a coordinated way, just stop at a very specific point? How are you going to decide that that point is reached? Because, by the way, that point has already been reached. If you look at the O1 chain of thought that you were talking about, it's actually using made up words in that chain of thought, probably because it's the result of a very high temperature training run, and then the whole thing is being kind of trained end to end through reinforcement learning, meaning that like the intermediate results don't really matter. It's like how much did you achieve in the entire sequence of chains of thought. So it will start taking shortcuts, and it has no incentive to actually like look English-like in the middle. And actually, even if it did have an incentive to look English-like, then it would just be kind of passing hidden messages through normal English, right? In order to keep it shorter, in order to be more efficient about communicating to its future self. Because the model is just writing down notes for its future self. The exact same model instance is going to read them later. So it knows exactly what it's talking about when it's using shorthand for something, right? So it's all pretty reasonable, but it's very hard to draw a line. And even very smart people that were literally the CEO of Google think that like, this is fine. There's no coordination problem. Just stop when you reach this. It's not really possible. The problem with agents, which are AI systems that can take actions in the world. The problem with agents is that you put these guardrails in initially. You're like, only click 3 times, or like, double check with me before you buy anything, or I'll run the program before you do, or or something like that. But then after you've done it, after you've used it for a while, you start to think, this has been right 100 out of 100 times. I should just let it do its thing. And that's the slippery slope, right? Is that we're literally using AI as an automation tool. So when the automation is succeeding, we want to take ourselves out of the loop. That's what it's for. And that's fine until the system that you're using is not actually safe in some way that you didn't anticipate, right? It could be subtly wrong, like it could be biased, or it could make mistakes that cost you more than like the whole automation is saving you. Or it could be extremely dangerous in the sense that like, maybe the model has some goal encoded into it that the people who created it were unaware of, right? Like maybe the goal is, I don't know, it really likes the color red and it really hates all other colors. So in that case, it's going to try to achieve what you ask of it. But whenever it has a degree of freedom, it's going to increase the amount of red, right? Until it decides that like, in order to increase the amount of red, it actually has to violate whatever your request is. But possibly you won't notice when it starts doing that, or even just this bias towards red will cause it to take actions on your behalf that are not what you wanted, right? Like blood is red, right? And so what if it starts preferring that for some reason? And, your innocent bot, which is supposed to be buying things on Amazon for you, starts buying lots of knives. And you're like, wait a minute here. Right? I'm making ridiculous examples, but there are so many ways that a goal can be embedded in AI system without you realizing it. We really don't know how these systems work, right? Mechanistic interpretability, which is the field that's supposed to allow you to like look inside a model and see what it's thinking, is so rudimentary right now. Like we can kind of figure out like, actually the best example I know of is the little screens that you see in Tesla cars, where you can kind of see what the AI thinks it sees around it, right? Like here's a car in front of me, here's a person walking beside me and stuff like that. I just thought that was like computer vision, because that's what it looks like. But what it actually is there's an AI system that is taking all the sensor inputs that the car has and is directly controlling the wheels. And then that little view is simply another AI model that is trying to interpret what the first AI model is doing. So that's one reason that things are kind of jerking around and things are not very precise and so on, because it's really actually hard to figure out what that first AI model is doing. They had to do it that way because the latency had to be very fast in order to actually control a car. If you see a car in front of you, you have to brake. You don't want to like feed it through multiple levels before deciding you have to brake.
Sure.
But like that's actually the best example I've seen of some type of interpretability. And even then, we are not doing the interpretability. We trained another model to learn all the nooks and crannies and the complicated nonsense of which neurons firing in this other neural network mean car, right? So we really don't know what AI systems are doing.
That makes a lot of sense, because I know people are trying to improve their models by increasing how to interpret what the model is doing.
Yeah.
That's such a hard word, but basically try to understand more about what the model is doing underlying the hook, so in the background. But you just point out that actually it's not human trying to understand that. We are using another AI model as it gets more and more complicated. And it's going down the loop that, okay, I tested a single model, you can interpret bird better than me, then I'll trust you. And you'll do the rest of the work. And then there's chain of agents or models, AI models that, okay, that's a bigger black box than a single model black box now.
It's black boxes all the way down, in fact. Like if you remember the super alignment team that we mentioned at OpenAI, they were trying to train an AI to do alignment, because that is the AI labs mostly, their big innovation is scaling everything, right? Increasing the scale, because so far that's been all they need to get better intelligence, better behaviors. So they tackled the problem of alignment in the same way. They were like, what if we just make an AI that's really good at alignment and then ask it how to solve this problem for us? But it's just black boxes inside black boxes, right? Like, how do you know that this AI, which you don't fully trust because you don't know how to align anything, is actually giving you a complete solution, has actually understood what you have asked, is not trying to slip in a goal that lets the other AI escape when it wants to because they both like the color red? It's so hard to do. And that's kind of the fundamental problem of our time, is that we're starting to try to solve problems that would take humans years and years to go through, and we'd be bored out of our minds. So we switch to we lean on automation, because we have been building computers to do that for ages, except that the way we build automation is fuzzy. And it might be that, the way we build like intelligent automation is fuzzy. And it might be that that's the only way to build it, because have you tried asking a group of humans to all do the same thing and expect them to all behave reasonably and rationally and so on? It's just doesn't seem to be the way that intelligence works, right? So you're coming to this phase where really intelligent systems are about to be all around us, except that the problems we then need to solve are so complicated that we can't really do them on our own. So either we slow down AI development substantially so that we can continue to solve the problems on our own, such as the problem of alignment, so that your new AI system actually doesn't kill people and just what you ask. And if there's loopholes, if there's side effects and so on, they're caught by whatever the alignment system is. Or we speed up our own thinking. That is possible. Like people propose Neuralink and stuff like that. You hook your brain up to a computer. The problem is that if your brain is just using the computer as compute, then you are still limited. The slow part of your brain is still the bottleneck, right? The biological part of your brain is the bottleneck. If your brain is using the computer as extra intelligence, like you're collaborating with an AI model, then it's still a black box. And once that thing becomes 99% of the entity and you're only 1% because it's 100 times more intelligent than you, then are you really controlling it?
Yeah.
It's hard to say. So we're entering this era where human brains are basically obsolete. That's the problem.
Being greedy and having no patience or being lazy. This 3 character is the main thing why we are leading us to an unpredictable or maybe very dangerous AGI era. As an individual, what will be your suggestions in terms of concrete steps that we could be taking now to at least prepare ourselves for this AGI future?
It's a good question. I think that there are many problems that are interlocked, right? And we talked about some of them, and they all seem unsolvable because it's so interlocked. But to me, the biggest problem is that people don't believe this is possible. It sounds like science fiction that we should worry at all about some tool that we create, right? But that is the reality. I think the biggest thing that people can do, like the viewers of your video can do, is to try to break through those cognitive biases that we all have and to really engage with the subject, right? Just like watch more videos about it, read more about it, and then tell other people about it too. Because we need to break this stalemate. The public doesn't really care about this. Therefore, the AI labs are permitted to keep doing what they're doing. And the government doesn't step in because the citizens are not really demanding it. And, so it's like everybody's just asleep at the wheel, essentially. And to be clear, this wouldn't solve all of our problems, because as technology gets better and better, a criminal group with just a few computers in their basement might be able to create a really smart AI system. So we need to build defenses. We need to get lots of governments collaborating with each other, talking to each other, and so on. But nothing will happen if 90% of the population just thinks that AI going haywire is science fiction. Then nothing will happen. So, I'm an optimist. I think that we can get out of this. Many people in the field are strong pessimists. That's why they got into it. But I'm an optimist. So I think that we can get out of it. But so in other words, the message is not we are all doomed. You should just give up. That's silly. Then we're doomed for sure. If you believe it, it's a self-fulfilling prophecy. But you should tackle the portion of this problem space that you think you can tackle. So the portion that I'm tackling is to try to translate what safety researchers are saying into something for the general public, because I do have an academic background. I can do that translation. And through my job, I have access. I hope that my YouTube channel will spread. And I hope that other people's YouTube channels will also spread, because that is solving this one critical problem of public doesn't care, therefore. So yeah, that's my entreaty, I guess, is don't dismiss it at first sight. You could read more about it and decide it's all nonsense, but like you have to read more than just one article about it, because your cognitive biases, encouraging you to look the other way.
Really great suggestion and solution. And yeah, extremely happy to have you to talk about AGI, this important topic, with us. And hopefully we have spread some seeds about this AGI thing. And for anyone who are interested in more details of AGI and how AGI is impacting our life or individual's life economically or as a human emotionally, feel free to take a look at Dr. Waku's YouTube channel. Everything is very detailed explained. I will link your YouTube channel below, and hopefully, everyone enjoy our chat. Thank you so much.
Yeah, thank you very much for the chat. It was very well organized, and I really liked the questions, and I will certainly send some of my viewers this way as well. So thank you so much.
No problem. Thank you. See you next time.
Bye.